Good evening, Professor. This is my personal timetable. So before to start this presentation, so I have to just summarize my the work and also to explain the future work that I'm planning in this week. So the task one is the coronavirus biosensor research paper. So as you given the deadline to the Prashant, that like today he have to be submitted, like to finalize the paper. So I'll do my. So I will fix it with him, and he probably finish until today, and he will deliver to you by today as well. So the second task is the PSA biosensor research. So, so the PSA biosensor research. Sir, in this research, I'm planning to uh, some modification, like to use as we have published one paper regarding this PSA, but this time we have the different PSA, and also we have to um, implement all the steps the same, but we use graphene oxide, and the second modification is we have to put first antigen, and then we have to make the different kind of concentration of antibody. So we have to mobilize onto the antigen, like we have to just reverse the process, like we have to first mobilize antigen, and then we have to mobilize antibody in a different kind of concentration. So these two modification I have planned, and tomorrow me, Ryunsang, and Dongmin first do the coronavirus research together using the LCR meter, and also um, you already said to fix the impedance analyzer at the fifth floor. So we have to fix it, and then we have to start with the impedance analyzer as well in this week. And simultaneously, I'm also working in the PSA case as well. And the third task is aptamer biosensor research. Sir, I'm I'm thinking about what kind of aptamer we have, and so we I got the solution as well. So once I discuss with you and Ryunsang about this mechanism, like what biosensor recipe I have to be implement on this task. So before to start this experiment, so if possible, so we have a small meeting together to know more about this, and so it's easy to if there is any comments or suggestion from your side. So before the experiments, it's easy to implement and to add on the biosensor recipe, and accordingly we have to start the experiment. So this is the coronavirus biosensor research paper. So it's almost done. In the afternoon, me and Prashant will check all of the things like the paper content and the figures as well. So we already fixed it, and hopefully today to Prashant will deliver to you for your final review. And the second task, I already mentioned about the second task, like PSA biosensor research. So it's already defined that we have to use the two modifications. The first one is to use the graphene oxide, and the second one is to immobilize first antigen and then immobilize antibody. So then we have to check the antibody and antigen binding, which is having the different concentration of antibody. And so this one is the detailed information of the aptamer biosensor research. So We have AMYM1. It's a code name of aptamer. Aptamer is basically it's a segment of the DNA. We call as a DNA primer. And so aptamer is capable of greater specificity and affinity than antibodies. As I already mentioned this slide, so I just revised this content and uh, before to start the experiment, so I have to again show you my research recipe and to discuss with you. So so basically, aptamer having the small size lead to higher number of moles of targets bound per gram, and it's having the better stability at ambient temperature than the antibodies. So that's why we prefer here aptamer, and we can tolerate transportation without any special requirements for the cooling. And this aptamer exists only in the below the 10 degrees Celsius. So uh, we have to manage it the room temperature and eliminating the need for a continuous cold chain as well. The aptamer is basically is having the two different kind of specifically is classified in two different points. It's a DNA and RNA aptamers and peptide aptamers. So in the decade, the DNA aptamers or RNA aptamers are basically rounds of an in vitro selection, or equivalently we have to follow the SELEX method. SELEX method is basically systematic evaluation of ligands by exponential enrichments to bind to various molecular targets such as small molecules, proteins, nucleic acid, tissue, and organisms. Peptide aptamers are basically artificial proteins. Peptide, it means protein. Protein is itself having the amino acids to bind with the specific target molecules. So these proteins consist of one or more peptide loops, and these are the basically typically isolated from the combinatorial libraries and to bind by direct mutation or round of variable region mutagenesis or selection. So this is the paper that I have found to know more about the aptamer because there are several methods for aptamer based biosensor design strategies. So here we have the 8 different kind of strategies to detect aptamer by the biosensing techniques. So first one is the simple binding based assays called ELISA, and then the second one is the B is a FRET binding including aptamer conformational change, and third one is structure witching aptamer design, and the fourth one is the aptamer in the presence of target molecules. So there are the various strategies to find to get the biosensing technique to deal with the aptamers. It's basically aptamer based biosensor design strategies, so we have to follow one of them. And so we have here the biosensor recipe. So we have to use P3, P6, or D5, uh, but we have less number of D5. I think, as per my knowledge, we have only 10 chip of D5. So we have to skip the D5 and for this research. So we have to use D3, D4, P3, and P6, any of them that which one is having large number. So we have to follow this piranha and the washing with DI, graphene oxide. It's a hot plate using for 1 or 2 hours at 80 degrees Celsius for, and it's a called annealing step. And then we have to use EDC NHS. So here we have, in the case of this, we have to use first antigen and then aptamer. So, and this is the basic information, like a specification of that aptamer, like we got from the Rinsang. And this review article. So today I have submitted this review article in the Bioscience and Biotronics, and hopefully we got the positive response from them. Um, Thank you, sir.